Hi, my name is Erica, and this is an update on the LIBI engine. The LIBI engine is a 3D engine I have developed entirely in C++ and using the Vulkan API for the rendering. It also uses a special nonlinear technique for the rendering that I developed specifically for this occasion. If you want more details about said engine, please watch the previous video. Although, yeah, I apologize for the quality of the said video because I use a camera to record the screen, and that was definitely not a very sensible choice. I was planning on using Android Studio this time around, but since the videos can only be up to 3 minutes long, I decided against it and went for the recording function of the Note9, although the consequences that the performances are obviously affected. So first of all, you can see that I added some new structures for the environment and also some new models such as these stone walls and stone floor. I also have some stairs over there and some the lights and beams and so on. First of all, I'm going to try to focus here on the corner of this wall. Yeah, I know this is not a very interesting thing, but the point is that you keep continuity while having sharp corners, although you made a mistake on the model here, which is one of the peculiarities of this rendering technique. Otherwise, about the stairs. So I basically use one model of straight stairs for this. And using this nonlinear rendering technique, I can basically make it turn around. I can change the height of the stairs. I can change the width of the stairs. I can change the angle. I can basically change anything about it. So this is a very flexible and powerful technique for rendering. I'm really happy about it. Although I had to make some improvements about the normals, because in the previous video, there were actually some issues with normal that were not accurate after the nonlinear transformation. It was especially obvious when I was using the stairs, so I had to fix that one using some new formulas. Otherwise, here you can see I made some cool looking suspended bridge inside a huge cavern, although you can't really see it because the viewing distance is only about 200 meters. But I'll try to implement a long distance rendering technique in the near future. It will be especially important when I want to render large scale outside environments. Happy about the speculators anyway. Otherwise, so as I was saying in the previous video, I tried to implement instancing for both Adreno's and Mali's GPUs. It improved the performance quite significantly on Adreno's, but I wasn't so successful on Mali GPUs. And the reason is that Mali GPUs only support up to 16 inputs for the vertex shader. That might be a lot for most rendering technique, but for this nonlinear one, that's definitely not enough, unfortunately. I'm already really pushing the limit by going down to 20, 21 inputs. I can't do much better. So if there are any ARMS engineer listening, please, really, you need to do something about it. I mean, I think the future is instancing and multi-draw indirect, so the numbers of inputs for the vertex shader is going to be very important. I don't want to keep using push contents. It sucks. It's very easy, but it sucks. Anyway, so better performances on Adreno GPUs for Snapdragons, but still poor performances on Mali-based Exynos CPUs. Really unfortunate. Otherwise, I implemented a texture level, texturing on the vertex level. By that, I mean that now I can choose up to 4 different color maps and 4 different normal maps for each triangle on the screen, as well as 4 different materials and 4 different colors. So it allows for a lot more variety in the environments. It looks a lot better too. You can use granite and then marbles on the same flooring, for example. As you are about to see here, the structures that define the environment is actually quite simple, which is why it doesn't take much memory to define one. As you can see about now, there you go. So as you can see, the structure for the environment is actually quite simple. It doesn't take much memory, but once you use the nonlinear rendering technique, it becomes a lot more complex and sophisticated. So this is a very powerful rendering technique. I'm really happy about it. It's not obvious here, but I also implemented some noise to make it darker in some part and lighter in some other part of the structures to add a little bit more diversity, so it doesn't become too obvious that I'm using the same model over and over again. Anyway, I'm quite happy about the results so far. Yeah, so what else to say? Not much. I mean, as I was saying, I need to implement the long distance rendering technique so I can make much larger environments and make outside environments too. So please look forward to the next update on say the engine. And thanks for watching. The video is going to keep on a little bit longer so you can see the rest of the structures that have been defined so far. And see you around. Bye.